បាទជំរាបសួរ Welcome to Laboratory of Applied Nanomaterials, or in short we call Nano Lab. So this lab has been established in 2014. At that time we have very few people to work in the lab, and we have very small room at the building A's. Now we extend our lab to STEM buildings, and our member also increase from few people now up to more than 10 people. I myself, Jay Chan-eun, working as the leaders of the lab, and we have another 3 PhD holders working as a researchers, that is a member of the lab. During this time, we have 2 PhD students under our co-supervisions, and also we have another 12 master students. So I would like to brief about the lab profile. So in our lab, we work in 3 different areas. The first area we call the synthesis of the nanomaterials. In this part, we synthesis nanomaterial based on low temperature growth synthesis techniques and also electrospinning techniques. After the material have been synthesized, so the material transferred to the second part for the characterizations. In this lab, we have all type of characterization techniques, including UV visible spectromet to measure the property of the nanomaterials, and also we have atomic force microscopy techniques. We have scanning electron microscope. We have XRD. We have XRF. We have solar simulators, and we also have advanced electrochemical analyzers. From this characterization techniques or method or facility that we have, we can understand the property of the nanomaterials. After the property of the nanomaterial have been identified, and then we move to the third part we call the application part. So the characterized nanomaterials have been applied in various applications, including biosensors, chemical sensors, light sensors, including solar cells technology. We are also working for LEDs applications, and also the accelerator sensors, and many different types of sensors. At the same time, we are also working on the photocatalyst property of the nanomaterial for energy harvesting technology. Recently, we have published different research papers on water splitting technologies based on the nanomaterials. So as you can see from our list of the publications here, and I show you some research activity in the lab here. So we have researchers to come here, and we have our sample, and we have people working on different applications here. So I show you briefly about the process of the research here. So here the synthesis nanomaterial based on low temperature growth techniques. From this technique, we can synthesize nanomaterial in different structures, including nanowires, nanoflowers, nanoporous, nanodisc, nanobell. So many different types of nano structures from that techniques. And then we move to characterizations. So the main equipment that we use here, SEM and EDS, to identify the morphology of the materials, and also we have others equipment like XRD, like AFMs, to identify the property of the materials. And the third place, that is fabrication process. It means the device fabrication. At this moment, the application of the nanomaterial we apply in different sectors, including sensor applications for medical device, and also the electronic device, including diode, LEDs, so on and so forth. And the nanomaterial also can be used for water purification systems, and also the air purification system. So here the potential application of our nanomaterials. I will show you some more facility. Here is our lab. You can see from this image we can have very good facility to do the printing electronic and preparations phase of the synthesis nanomaterials. And here some infrastructures that we have here, like a scanning electron microscope, electrospinning facility for synthesis nanofiber, especially carbon nanofibers, and XRD to identify the structure of the nanomaterials. So in conclusion, our lab now, we have facility for synthesis nanomaterial. We have advanced facility for characterization of the nanomaterials. We have facility for printing electronics to fabricate device, especially for flexible electronics. And our material can be used for various applications, including energies, waters, and environment applications. Thank you.